Hello, my name's Kathy Russell, and I am leading this project for the Melbourne Waterway Research Practice Partnership, Major Sources and Fates of Sediments in Streams, Wetlands, Estuaries and Bays to inform management opportunities. We are collaborating with RMIT A3P on their project Impacts of Sediments from Urban and Rural Stormwater on Stream Health, which is focused more on pollutants, and with some institutions in France on the project New Monitoring Technologies, serving a better understanding of land and river degradation in urban areas. The background to this project is that we know that receiving waters, waterways, estuaries and bays, are sensitive to changes in sediment load. Western Port is an example of a particularly sensitive receiving water. It contains seagrass beds that are under threat from light attenuation by suspended sediment. We know from a range of work that's been done mainly by Melbourne Water and CSIRO over the last 2 decades, that the sediment that's accumulated in the bay will continue to flush out of the bay slowly, as long as the catchment sediment inputs can be kept at or below what they currently are. And so based on that, a sediment load target has been set in the new SEP waters to allow sediment to flush from Western Port. So Melbourne Water is now intending to develop an environmental management plan with DELP and EPA to achieve that target. And so they need to understand where the sediment loads are coming from and what management actions might be appropriate to address them. And now sediment loads from the catchment are reasonably well understood through sediment budgeting efforts with CSIRO, but there are still a few uncertainties. There is a key knowledge gap around the sediment liberated by different stages of urban development in the catchment, and we have a growth area, the Southeast Growth Corridor, pushing out through that catchment. And there's still a need to better quantify some aspects of the sediment budget, including gully erosion, bank erosion, and sediment deposition and resuspension. We're expecting this project to produce these 4 outcomes. So firstly, improved conceptual models of the urban and rural sediment budget, quantification of the role of urban construction and different urban construction phases in sediment supply, providing validation and guidance to improve sediment budget modelling, and recommendations and tools for prioritising management interventions. And so the benefits to Melbourne Water that we're expecting for this project are to inform plans and strategies to decrease sediment loads to Western Port. So this is around that environmental management plan to keep sediment loads at or below where they are currently. We're expecting it to support improvement of the Western Port sediment budget and hydrodynamic models, and to potentially inform changes to sediment control guidelines and regulatory arrangements more broadly. Our collaboration with RMIT is all about pollutants, and so that's expected to improve understanding and management of pollutants, particularly pesticides, during urban development. And our collaboration with CNRS in France is all about novel monitoring technologies. And so that's expected to lead to more cost-effective sediment monitoring to support greater temporal and spatial coverage of data, rapid deployment to monitor short-lived or quick impacts such as monitoring compliance at construction sites, and improved maintenance and field safety so that we can have virtual eyes on our sites without actually having to visit them. The methods that we're using, firstly, we are doing some land cover analysis and developing conceptual models for the way that the way that land proceeds through the construction process, and what happens to watershed processes through that sequence. So what happens to runoff and potential sediment supply as land is urbanised. We are doing sediment sampling and surveys. So this is our main field component that we are trying to quantify sediment load at 4 sites within the Western Port catchment and develop sediment budgets for those catchments, understanding where the sediment is coming from and which phases of urbanisation or activities in the catchment are most important. We have 2 PhD projects, both on novel and low-cost sediment monitoring. One of them is focusing on the hill slope processes or the catchment generation of sediment. The other one is focusing on sediment transfer, deposition and resuspension in the waterways. And finally, we have a few smaller components of sediment budgets and sediment processes that will be studied through honours and master's projects. So our progress to date has been that we have produced a literature review looking at conceptual models and past empirical models of how construction proceeds and how that impacts on sediment generation, and also looking at the local context in the Western Port catchment. We've done a desktop analysis of construction patterns and developed our own new conceptual model for how construction occurs in Melbourne's growth areas and how that affects potential sediment supply. And then that will guide our field monitoring. We have installed 3 of our monitoring sites, and if the 4th one is scoped and planned. We had some issues with low gradient at the first site that we installed, and so we've partially addressed that by managing in-stream vegetation and upgrading a farm crossing downstream. And we've also looked at novel solutions for monitoring flow in low gradient streams using things like differential water level gauges and velocity gauges. We have ethics approval for installing automatic cameras so that we can see our sites remotely. We've developed a collaboration with France on low-cost sensor development, and so that's being led on the French side by Frédéric Cherki. We commenced a gully evolution honours project this year, and we produced an online learning seminar for Melbourne Water on construction site impacts. Our proposal for the coming year is focused on 3 things. So the first is sediment load monitoring and sediment budgeting, and this is our main fieldwork component. So we are planning at our 4 sites, we're planning to sample sediment with auto samplers and use that and combined with flow gauging to calculate event sediment loads and annual sediment loads. And then based on that, we can construct a sediment budget for these catchments. So understand what's coming in, what's going out, and what might be coming in from the catchment in between. We're also planning to do some survey of sediment ponds and stormwater assets to understand what might be captured within the catchment, and the creek to understand whether that's eroding or undergoing deposition. Secondly, we have our PhD projects. There are 2 of them. One we are hoping will start in March in Melbourne, and he will be looking at the variability of hill slope erosion and sediment delivery in peri-urban catchments. So he's very much focused within the catchments. Can we use novel monitoring technologies that are lower cost than traditional sensors to increase our sampling resolution or our sampling extent and coverage to better understand variability? And the second PhD project we are hoping to recruit next year, that will start late next year in France, looking more at sediment transfer through streams in peri-urban catchments. Now, third component is the Honours and Masters project. So we're hoping to recommence the gully erosion evolution and activity levels project this next year. And we'll advertise another Masters or Honours project, which is about the effects of soil disturbance activities on construction sites on infiltration and runoff. So looking at that hydrological transformation over the construction process. So thank you. I just wanted to acknowledge there's a huge team working on this project, and from all of the different institutions involved, and I wanted to acknowledge all of their work. And if you have any questions, please don't hesitate to contact me. My email is there on the screen. All right, thank you.